Good morning, everyone. Welcome to the second day for Power Plant Summit. We really thank you for your participation. I hope yesterday was really good for you. Today also we have some really great presentations lined up, some interesting presentations. With this, I would like to start the first session. First of all, let me welcome our session chair for the session, Mr. Prasad Rao sir. Mr. Prasad Rao sir has more than 35 to 40 years of experience in thermal power plants. He's retired right now, but working as independent consultant, and he's disseminating knowledge about thermal power plants to several people. Sir, request you to please start the session, sir.
Yeah. Good morning, everybody. This is the day 2 of Power Summit 2021, the 17th edition. In spite of COVID-19, CII is doing a great job organizing the seminars seamlessly through web portals. Yesterday, I could participate in a day 1 program, so it's very, very interesting. Today's the topic is biomass, renewable, and other alternate energy utilization systems in TPS. This is under the theme of achieving world-class standards for thermal power plants through improved efficiency of energy management and flexibility of operations. We have 4 panelists today. All 4 are very distinguished personalities in their respective fields. The first topic will be flipping the script at the legacy coal-based power plants from USA, Mr. Lincoln Blevins. Welcome to Mr. Lincoln. He is Executive Director, Sustainability and Engineering Energy Management. After that, we'll hear from NTPC team, Sri V.A. Surendra, Deputy General Manager, who will talk on biomass utilization at NTPC. NTPC has done a remarkable job, and they are trying to utilize biomass at various power stations. And third in the presentation will be multi-fuel firing and boilers by Mr. Castor Chagad from BWSC India Private Limited, followed by floating solar power plant by A.K. Shukla from NTPC. He is the Additional General Manager. These are the topics where alternate energy solutions are will be put in place. You know that coal-based power plants are the source of emissions, and all the countries are working towards finding alternative solutions for the coal-based power plants. In that direction, many of the countries are harnessing wind energy, solar energy, biomass, and alternate energy by producing hydrogen and hydrogen-based power plants. With this opening remark, I request Lincoln Blevins, Executive Director, Sustainability and Engineering, to take forward with his presentation. Thank you.
Very good. Let me set this up here. Okay. Can everyone see that?
Yeah, please go ahead.
Excellent. Okay. Good morning, everyone. My name is Lincoln Blevins. Thank you for that kind introduction. I'm speaking to you from Los Angeles in Southern California. I wish I was in India. It would be a lot more fun, but maybe next year. My topic today is the marriage of old coal-fired power plants and new green hydrogen. And what I'll be talking about is not theoretical. It's actually happening not too far from here in the state of Utah in the southwestern United States. I have about a dozen slides, and I look forward to your questions. So I wanted to start out, this presentation is based on an article I wrote recently that ended up getting published in 2 different industry magazine or websites, Utility Dive and Green Biz. It's the same article, different pictures, same words. And so I would encourage you to look those up if you're looking for additional information on this. So let me start about 250 years ago with the beginning of the Industrial Revolution. The Industrial Revolution kicked off economic growth like the world had really never seen. Lots of things got a lot better very quickly. But as we've come to realize, the Industrial Revolution also started the planet on a slower moving but incredibly destructive path called climate change. And that revolution, the Industrial Revolution, was powered in substantial part by electricity. And a lot of that electricity was powered by coal in the US. As we race to mitigate climate change, the cost structure of coal alternatives has pushed coal to the sidelines here. Renewable energy in particular has gotten remarkably cheap. And even natural gas has become less expensive than coal with the advent of enhanced production techniques like fracking and horizontal drilling. And that's left a lot of things stranded, jobs, investments, tax revenue, and the whole economic ecosystems that have grown up around these plants over the decades. So my view is that we can and must do better, both in the US and around the world. The energy industry, in my opinion, is going to change more in the next decade than it has in the last century. So much so that I think our grandchildren will be jealous that we got to be in the energy industry in the 2020s. But that transformation never, that flood of transformation never raises all boats. The Industrial Revolution sacrificed the environment in the name of the economy, and the climate revolution threatens to sacrifice livelihoods of a lot of hardworking people for the environment. We can and must do better. And so I'd like to talk about how we can do that. So let's go back to that boarded up coal plant a couple of slides ago. It's very easy to look at that and see days gone by, but that's not what I see. I see a prime industrial site ready for redevelopment. I see a motivated community and a highly skilled workforce. I see infrastructure waiting to be repurposed, transportation from road to boat to rail to pipelines, water in abundance, and high voltage electrical infrastructure like transmission and substations. Then let's take those facts, let's take that reality on the ground and rewrite the equation for the age of climate change. Let's add technologies around green hydrogen production and end uses from gas turbines to transportation to industrial processes. And perhaps most importantly, let's recognize that the age of climate change is changing the very metrics with which we measure success. Economic costs in dollars, as we always have, but also environmental costs in dollars, greenhouse gas emissions, and pollution, as well as environmental justice issues and social justice issues. Success isn't as simple to measure anymore, and that's okay. So anyone who's developed power plant projects will probably recognize this form of slide where you have a site in the middle and technology, and then you have inputs on one side and outputs on the other. But you'll notice that this is a little bit different than the usual fuel in and power out of a traditional power plant because we're literally flipping a lot of the assumptions. We're taking the electrical infrastructure, and instead of using that to export electricity, you see that we're running it the other way. We're bringing renewable energy in from the grid as opposed to sending energy out to the grid. And instead of using all that water for steam and makeup water, we're using electrolyzers at the site to break it into green hydrogen and oxygen. And like the coal plant in days gone by, we're producing both a valuable product, green hydrogen, and tax revenue, while recreating the very virtuous circles for the local economy and society. So it's a very similar structure, but again, taking some of the inputs and making them outputs, and taking outputs and making them inputs. So one of the challenges with this model is that traditionally making hydrogen with electrolyzers has involved a tremendous amount of very expensive electricity. And obviously you still need a tremendous amount of electricity, but at least in California, here in the US and California, the cost of electricity has really undergone a massive, massive change. We're seeing, because of solar production, we're actually seeing negative pricing. In other words, loads being paid to take electricity off the grid, almost like a tipping fee if you had a trash burning plant. So one of these major inputs, the electricity, has gone from a cost actually to a negative cost. So the whole price structure has changed, and that's a whole new world. And I actually think that the California experience will be replicated around the world, especially in places with a lot of solar power. That said, there's a big challenge, and I want to recommend an article by a couple of colleagues and friends of mine, Bob Schulte and Fred Fletcher. It was just in Power Engineering, and it talks about the cost of green hydrogen as compared to the capacity factor of the renewables that are being used to produce it. And when you look at solar alone at about a 25% capacity factor, you're looking at very expensive green hydrogen on a dollars per kilogram basis. You really need to find a way, whatever the particular market will offer in terms of diversification, in terms of energy storage, so that you can drive up the capacity factor of the renewable energy that you're using, and thereby drive down the cost of the green hydrogen. This is something that we all need to work on, and I would really recommend this article for folks who want to dig into this. So this isn't, like I said at the beginning, this isn't all theoretical. This is actually happening about 1,000 kilometers from here at a place called Delta, Utah, which is a very small town in Utah. There has been an 1,800 megawatt coal plant there since the mid-1980s that has served Southern California, including the utility that I worked for until very recently, Burbank Water and Power, which is where Hollywood is. And what we're doing is taking that 1,800 megawatt coal plant, we're turning it off. We're switching it off in 2025 and switching on an 840 megawatt natural gas and hydrogen combined cycle facility at the same site. And that will provide baseload power, of course, but also tremendous renewable integration, which is desperately needed in this part of the country. We're starting off with 25-30% green hydrogen to be produced on site. And Mitsubishi, our OEM, has promised that they will get to 100% green hydrogen firing capability within about a 10-year period. So this is going to be an absolute key to Southern California's clean energy, sustainable future. The other interesting thing about that site is that there is a very interesting geology there and a very real possibility for compressed air energy storage, which would be very large scale, very long duration storage right at the site. And that site is connected to Southern California with a almost 488 mile, about 900 kilometer direct current line that is dedicated to getting power from there to here. So it's a really, really interesting project and happening as we speak. So let's take that globally. This is a heat map of all the coal-fired power plants in the world. And it's about, it's over 2 gigawatts, I think about 2,400 gigawatt, I'm sorry, 2.4 gigawatts of coal-fired power across the world. A lot of that is getting retired in the US, getting decommissioned as we try to decarbonize. But elsewhere in the world, there are plants still under construction, China in particular. So when you think about it, though, you think about the model that I've just described to take a legacy coal plant and turn it into a green hydrogen plant. The fundamentals are really the same, no matter what language we're speaking. You have the site, you have the workforce, you have the water, you have the electrical infrastructure, and increasingly all over the world, you have not just an abundance of renewable energy, but often you have too much renewable energy, especially during the middle of the day when the sun is shining. So I see this model as potentially applicable literally all over the world. And frankly, we're all in this together. If the last couple of years have taught us anything, it's that what happens in one part of the world is going to affect things in the other part of the world, whether that is politics or climate or what have you. So when I look at that map of all those coal plants, I think this is something that we can think about applying to our situations no matter where we are, because decarbonization is how we get through this, is how we get through climate change. So with that, I want to thank you for your attention. And I don't know, Prasad, if you want to do questions now or you want to do questions after.
Yeah, sir, we'll take the questions at the end of all the sessions.
Okay, very good.
Yeah. Thanks, Ms. Lincoln. It's nice information given for repowering the conventional coal-based power plants to hydrogen-based green energy solutions. I'll be interested in talking to you so that how it can be taken forward. Very, very interesting topic. I hope everybody, all the participants and the panelists must have got valuable information from you and how US is taking a lead in this. I'm sure with this we'll be able to meet the Paris Summit guidelines and the commitments given by all the countries. Thank you very much. Next in the list, biomass utilization at NTPC by Mr. V.A. Surinder, Deputy General Manager. Surinderji, you are ready now? Hello.
Ready? Just a minute. I will share
Yeah.
my screen.
Yeah, please. Please.
Is my screen visible, sir?
Yeah, please go ahead. It is visible.
Just a minute. I will share.
I think we should go in slideshow mode.
Yeah, sir, it's opening. Yes. Yeah, it's opening.
Yeah. Yeah, please.
Good morning to all of you, sir. Actually,
Good
I
morning.
am V.S. Surendra, working in NTPC as Additional General Manager in Operations Services Group, which is basically the strategy making group for the NTPC units all across NTPC. Going ahead, sir, I will be sharing with you our experiences in NTPC stations with respect to biomass pellet firing. We normally see in newspapers that there is so much stubble burning going on, which is causing a lot of pollution problems in our capital city and around that area in North India, especially. We can see this type of news items coming in the newspapers frequently in the crop cutting season. This is basically due to stubble burning that is happening. It is continuing in to smother the North India a lot. And going ahead, sir, this stubble burning is one of the biggest problem in North India during crop cutting season. And how big it is? If you see, crop residue, we are producing around 500 plus metric tons. Out of this, we are burning 120 million tons approximately. 100 to 120 tons will be burning, and which is giving out 176 million tons of CO2, which is simply going as the waste heat energy into the atmosphere and is causing lot of problems also. Like stubble burning causes loss of nutrients to the ground, and mortality of soil bacteria is another issue we face because of this stubble burning. And soil hardening and erosion, this is one more issue we face. And moreover, particulate emission, which is causing a lot of pollution issues in our country. And on top of all these things, we are losing a huge amount of heat energy to the atmosphere, which is a great concern for people like us who are in the energy industry. How this is a source of pollution, if we see in Uttar Pradesh, Punjab and Haryana contributed to around 60% of the crop burning that is happening in the North India. Whereas if you see the statistics, even if you burn 1 ton of crop residue on the field, it releases approximately 1.4 tons of CO2 and around 58 kgs of carbon monoxide and particulate matters of 11 kgs and 4.9 kgs of NOx, 1.2 kg of SOx. And this is as per the analysis by Center for Science and Environment Analysis. PM emissions from the crop burning are also very high, and 17 times the total annual particulate matter in Delhi alone itself. This is the statistics if you see, and this is the proportion of the pollution that is caused by the farm fires, and this is due to crop residue. And crop wise, how much residue we are generating? If you see, around 500 to 560 million tons of crop residue is produced on an annual basis, and this is estimates. And out of this, maximum is coming from wheat and rice. These are the major contributors, and this is surplus residue is around 260 million tons. This residue is going waste as the fire and heat energy is lost from this residue into the atmosphere. And out of this also, sugarcane is maximum. Wheat and rice are also there, but some amount of utilization of the residue is taking place in the rice and wheat, whereas in sugarcane it is not getting utilized properly. And what is the solution for this? Solution for this is we can use this heat energy that is available in the crop residue by converting them into biomass pellets, which is we can say a carbon neutral fuel. May not be 100% carbon neutral, but we can say more or less in terms as a carbon neutral fuel. If you see in the cycle, we are consuming around 63 to 102 kgs of CO2 for producing this biomass pellets, whereas we are saving around 1181 kgs of CO2 emissions, as a net saving, there is a net saving of 1181 kgs of CO2 per ton of biomass pellets we consume. This is the basic advantage we get from doing this thing. And what are the government initiatives for this in thermal power sector for utilizing the biomass pellets? If you see, Government of India has issued an advisory for co-firing in the pulverized boilers in 2017 itself. The policy goes like this: in order to promote use of biomass pellets, all fluidized bed and pulverized coal units except those having ball and tube mills of power generating utilities, public or private, located in India, shall endeavor to use 5 to 10% blend of biomass pellets made primarily from agro residue along with coal after assessing the technical feasibility and safety aspects. This is a guideline that has been mandated by our Government of India, and taking cue from this initiative, this policy, we have gone ahead to implement biomass co-firing in some of our units. If we see what are the benefits for this biomass co-firing, is that it's a win-win situation for all the farmers and environment, and even for us also, we get some amount of heat energy from this, and we can reduce the pollution, so reduction of SOx and NOx, and we can neutralize carbon footprint by biomass co-firing, and this is a new source of income for farmers, and the employment generation is possible in biomass industry. These are the 4 advantages we get by biomass co-firing. And if we go further into the details, what are the different methods where we can co-fire this biomass in our plants? This is by direct co-combustion or indirect co-combustion or parallel co-combustion. But we'll be seeing more about direct co-combustion only. But we have adopted this method of direct co-combustion in NTPC. And whereas this indirect co-combustion, there will be gasification of this biomass, and parallel co-combustion, there will be separate boiler for biomass altogether. This is a method, but we'll be concentrating more on the direct co-combustion only. This is only what we have adopted in NTPC. If we see the properties of coal versus paddy straw, if you compare alongside both the things, the major deviation we find here is that in paddy straw, we find more volatile content, more amount of alkali metals and alkali earth metals, and chlorine content is also high compared to coal. These are the 3 areas which will cause some problem for us in case if we start burning them in our boilers, co-firing of the boilers. And if you see, sir, coal versus paddy straw ash analysis, ash produced analysis, in this you can see more of the products produced by alkali metals and alkali earth metals in the ash, and biomass ash is characterized by a low melting temperature and high tendency to slagging and fouling. So if we start increasing more amount of biomass, these problems will get. But up to 5 to 10% of mixing with coal, we may not. And if we see this impact of biomass co-firing, biomass composition in this co-firing, we can see how they are going to affect our performance of the units. If you see, there is a substantial proportion of volatile matter in this biomass. This is a positive factor. It improves the flame stability, but at the same time, it produces a risk in our pre-processing system. That is fuel pre-processing system, where there is a fire explosion risk is there. In addition to this, biomass has less ash and sulfur than coal, but high moisture, chlorine, alkali, and alkali earth metals. This is rich. Biomass is rich in alkali and alkali earth metals, chlorine, and moisture. Sodium and potassium may react with sulfur and can produce alkali sulfates, and the vaporization and subsequent chemical reactions will be producing fouling, corrosion, and silicate formation in our boilers. This is one of the risks we'll get because of this co-firing. the risk. However, up to 5 to 10%, it is seen internationally also. We do not have any major problem if we only mix up to 5 to 10% of co-firing, mixing with the coal. Then on environment, how this biomass co-firing is going to affect. In case of CO2, it is almost it is neutral. We can say it will not increase CO2 emissions. Co-firing will reduce emissions by almost that much as we are saving our coal. Anyway, this biomass is going to be burnt in the fields. So that much again we are burning here. So in our country, we can consider it as a saving in the CO2 emissions. We are reducing the CO2 emissions by that much. And in case of SOx, biomass generally has much lower contents of sulfur together with high concentration of alkalis. So SOx also will get reduced. NOx, in case of lower flame temperatures, thermal rocks will get reduced. It can reduce NOx also through lower nitrogen content in the biomass. And in case of particulate matters, our ESP is up to 5 to 10% of our mixing with the coal. Performance may not get affected, but in case if it increases beyond that, due to high resistivity of fly ash, PM 2.5 emissions can increase. This is the impact of this biomass co-firing on the environmental parameters. And ash utilization, this is one of the core area where we are utilizing ash. Our ash is totally being used in the cement industry as the as a product for making the cement industry. In case of this EN 450 standard, specifies only for pure coal or anthracite combustion ash, whereas 452 standard, it's a revised, and in this it can allow maximum ash content up to 10%. That is, the co-combustion material is not ash produced because of the co-combustion should not increase more than 10% of the total ash produced. And in addition to that, the chloride levels in grass and straw in worst cases allowed co-firing may go up to 10%. This is the disadvantage here. And the co-fired ash does not pose any increased risk of health risk because this is not producing any dangerous substances in the combustion. This is also one of the point we can think of. So this is about basic concept we have discussed about it. Now coming to NTPC's experience in biomass pellet firing. In NTPC, we have started this, we have used this direct co-combustion philosophy for co-firing, and our NTPC Dadri is the first station that has used this biomass pellets as co-firing along with coal. And we have monitored the boiler performance during the biomass co-firing. Based on the experience of the Dadri, we have further identified 14 stations for biomass co-firing. So now we have got 15 stations where we are trying to fire biomass. Out of the 10 stations already started firing, remaining stations are yet to start. What is the strategy we have adopted for biomass co-firing in NTPC? And first, initially, we have formed a task force for identifying the issues in firing of the biomass, And in Dadri, we have conducted trials. We started with the 2.5% in one mill and then increased up to 5%. And based on this experience we have gained, we have issued a operation guidelines for entire to be implemented across NTPC stations. At the station level, this operation guideline will be further converted into local management instructions, LMIs, which will address the responsibilities and checklist to be prepared for taking necessary actions. And these local management instructions shall have standard operating procedures also for all the activities in details, how to do the handling, how to go for blending, how to handle it, how to store it, how to do the activities of storage, how we have to go ahead with combustion improvement, and what are the parameters to be monitored like that. All these things will be explained very in minute details in SOPs. Then for biomass co-firing, there are two steps involved in the co-firing, that is handling, storage, blending of the pellets. This is one part where it is only handling. The second part is the combustion monitoring of the biomass co-firing. This is the second part, which is very important for us. For handling, storage, and blending of pellets, sir, first we'll be going for receipt and unloading. Nowadays, we are getting biomass pellets only through road. There is no, this industry is in the very nascent stage where pellets are only being transported through lorry transport. There is rail transport system is not yet to start. That much mass production is not being there right now. So we will, after getting this in biomass pellets, we are unloading them in the identified areas in CHP, coal handling plant. Then we'll identify and we'll keep them covered with this thing, because these are also very hygroscopic in nature. Basically, biomass pellets are hygroscopic in nature, because these facilities, these are the facilities where the moisture should not enter, and at the same time, these biomass pellets are having high amount of volatile matter. So they should have the facilities. The area where we are going to store should have the facilities for firefighting, and facilities should be developed to transport from storage area to blending area. That is up to the claiming hoppers area or area where we are going to blend it, where we are going to put it onto the conveyor. Till that area, we should have the facilities for transportation. And blending and bunkering of the pellets, blending ratio we have maintained only up to 5%. Will not. We have decided not to go beyond 5%. And in this case, what we have done is we have site specific. Every site is different with respect to configuration of the coal handling plant. So for this purpose, what we have done is every station will identify where the blending shall be done. That is the point where it is blending is done, and the methodology, how they will feed it to the pellets, and the chute or TP transfer point where blending shall be done. Then what is the control methodology? How we will control, whether we have to use the beltway scales or whether beltway scales are not available, then implementing them. And number of bunkers where we will be using these pellets for blending, and how much level we have to bring down for accommodating the pellets in the bunker, because in a day we are getting some particular time only pellets. We are not getting on a continuous basis. So we are monitoring the levels also in the bunkers where pellets are to be bunkered. Strategies for blending in Dadri is that there is a track hopper and the reclaim hoppers are there. And from reclaim hoppers, we are feeding biomass, and track hopper, we are feeding coal. And at the transfer point, we are combining both the things and we are blending it to the identified bunkers only. We are not doing in all bunkers. Of course, we have done modification in all, but we will be identify and put them in those units and with the information to the control room. And in Mauda also, these are the points with marked as yellow. These are the points where we can use biomass pellet. We can, and from here, from TP12, most likely what we are doing is we identify TP12 as the point where we'll be mixing biomass pellet with coal. And these are some photographs where we have shown the how the biomass pellet is being conveyed through conveyors. These are the reclaim hoppers where we will be feeding biomass pellets, and we are using material handling equipment for transporting from storage area to reclaim hoppers. And coming to the type of biomass we have used and analysis of the biomass, almost we are getting equivalent amount of GCV. This is the pellets what we have used in one of the stations where GCV is around 4,000. It is moisture is very less, 6%. Ash is 14%, and volatile matter you can see it is very high. That is 55 to 65%. You can see as this is 55 to 60%, and per truck it is coming as the 30 tons we are getting. So for handling this biomass, what are the precautions we have taken while the unit is in operation? The first thing is that in fuel pre-processing system, we have ensured that mill inerting system is charged up to mill inlet to take care of any fires that can happen.
Mr. Surendra, if you can conclude in a minute.
Yeah, I saw, sir. It's only 1 minute or 2 minutes. And we have provided, the wall provided is that inlet, it is from operable from control room. Then mill inlet temperature control loop, we have changed. So we have done some modification where it can control inlet temperature of the mill. And similarly, mill hot air gate also there is a protection provided with mill inlet temperature. And we have prepared SOP for unit operation with biomass. And biomass co-firing status, sir, if you see, we have fired around 50,000 tons of biomass till now in NTPC. And mostly the Hadri and Moda stations together, we have fired around 35,000. The blending is being done from 5% to 1% pellets with coal, depending on the availability of the pellets. And the issues we are facing here is that supply is very irregular supply of pellets due to poor pellet manufacturing capacity and poor stacking of infrastructure pellets. These are two things. Thank you.
Thanks a lot.
These are the
Mr. Surendra, it was very interesting. There are a few questions will be coming at the end of the session. Next topic, multi-fuel firing by BWSC India Private Limited.
Yes,
Mr.
my name
Sogad.
is, yes, thank you very much for the introduction. Let me see if I can share this presentation. Is this visual on the screen now?
Yeah, we are able to see it.
Okay, very good. Very, very good. Okay, gentlemen. First of all, my name is Karsten Sogard. I'm representing Burmeister and Wain Scandinavian contractors in Denmark and India. And I am presently located in Copenhagen, Denmark. And thank you for the invitation for this presentation and the opportunity to present BWSC and some of our technologies and visions for the future. So I will go through a short introduction of BWSC, some of our boiler concepts, references, and of course speak a little bit about multi-fuel firing, as we just heard a little bit about co-firing in Indian power plants. But I will also speak about some of the issues regarding agro biomass fuel, some of the difficulties and challenges that NTPC already is entirely aware of, and also how boiler design can be adapted to take on these challenges. BWSC has really a long history. It reaches back to 1843, 46, and has primarily been doing its business on diesel engines and diesel-powered ships throughout most of its life. But the division called Burmeister and Wain Scandinavian Contractors and Burmeister and Wain Energy was divided or separated from this mother company in 1980. And these two companies have actually just recently in 2017 been rejoined into one company. We built our first straw-fired boiler in the 90s, fired by agro fuel, cereal straw, and our first ultra supercritical boiler in the late 90s, and this biomass, which later also was converted into wood pills. I'll go through a few of the details on this a bit later. On the biomass boiler side, UK and Denmark has been really good markets for us. We are talking about 10 to 50 megawatt electrical biomass, fully biomass fueled power plants designed for agro biomass, and we are seeing now an increasing interest in India for our technology on this matter. So basically, the boiler division in Burmeister and Wain, which I represent, is focusing primarily on boiler design and boiler conversions. And around the boiler design is primarily biomass, agro-biomass boilers. We have great technology in the fuel feeding system beside the entire boiler design. And we also are specialized in fuel conversions of large utility boilers like what NTPC just was talking about, at least co-firing. We are focusing more on entire conversions and also multi-fuel firing in boilers. That can sort of be congested down to three elements. The first line here, the fuel conversion in the size of 100 to 800 megawatt electrical. We have a number of references in that. But most and foremost, our biomass boiler focusing on agro and forest biomass in the size of 10 to 50 megawatt electrical. It doesn't sound of much when the total sort of power fleet of the world, we are talking about gigawatts, probably even a lot more than that. But that's the size that is adaptable to agro fuels when we consider all aspects of the business model. And then we have one reference on a hybrid where we combine grate firing, which is primarily our biomass boiler built on grate firing, combined with dust firing. This is our reference Evler 2 in Denmark. This is a ultra supercritical boiler that was designed and built in the late 90s. It was originally designed as a coal boiler, but the political establishment at the time here was already aware of the damaging effects of fossil fuels. And for that reason, permission for coal operation was simply not given, even though it was originally the intent. But instead it was commissioned in natural gas, which, despite being a fossil fuel, was considered a lot less harmful at the time, which it in principle also is. But already 3 years later, after the commission on natural gas, it was decided to convert this boiler to to pulverized wood pellets, which was considered a carbon neutral fuel. And there's a great deal of discussions going on whether it is or it is not. I mean, I think it's pretty evident that it is. It's a matter of how you consider it and what cycle your aspect is you're putting onto that. It's certainly more difficult to see the annual cycle or the cycle of the carbon dioxide neutrality of it on a short-term basis. But for sure, on a long-term basis, it should be considered as such. Anyway, the conversion of this boiler was made through minor modifications of the burners and the roller mills, and in this way, this plant actually became not just a ultra supercritical reference for BWSC, but also a coal boiler reference, a multi-fuel reference, but certainly also our first fuel conversion reference, possibly the first in the world, but certainly the first ultra supercritical boiler. It's today operating on 360 megawatt electrical, 100% wood pellet firing, and consuming around 180, 190 tons an hour. The political opinion against fossil fuel and building on the success of the Evler 2 was leading to the conversion of Amager 1, Unit 1, which is a subcritical boiler, also originally built by Burmeister and Wain for coal, but it was converted to wood pellet and straw pellets. Straw pellets being an agro biomass and commissioned in 2009. But because of straw pellets have particular characteristics, chemical characteristics that that are, so to speak, challenging and difficult in a boiler designed for coal. And we already heard a few of the reasons, but I will get back to that later. The straw pellets was very quickly abandoned as a fuel in this plant, simply because of slacking issues on the superheaters. This was something that we were aware of, but we considered the design carefully. And but however, we faced some difficulties that led to abandoning this fuel. Now, moving on to India in 2009, we moved into the Indian market with the establishment of an Indian division now known as BWSC India. And the acquaintance with ESSA Power led to the order of the Hasira captive multi-fuel power plant of 2 times 150 megawatt in 2010. It was commissioned in 2014-15, I believe. This was also a subsea 2-pass boiler with a total of 20 low NOx multi-fuel burners that could take off the waste fuels from the ESSA steel mill that was just located next to that, and had the capacity of burning a large variety of fuels, among them Corex gas, coal, fines, fuel oils, not the environmental nicest fuels, but they were waste fuels from the steel mill. Here we see a picture of the Corex gas burning in the boiler. There's a nice and blue flame there. So in principle, what we can say about BWSC or BWE polarized coal boilers are that they're in principle all biomass ready. There's no carbon lock-in. Biomass, however, has to be seen in a more narrow perspective. Not all biomass fuels are equally adequate for transitioning polarized boilers into polarized biomass burning. There is a large limitation in this. But the bottom of it all is that relatively minor modification is needed and limited investments, but they need to be returned for sure. And for that reason, some sort of carbon penalty or green incentive needs to be added to such a conversion or transition from coal to pulverized biomass burning. An example of our multi-fuel burner for the Evidure 2 has a total capacity of nearly 50 megawatt on natural gas and 30 megawatt on wood dust. This is the multi-fuel burner for the Hasira plant, having the capability of burning Corex gas and coal dust and heavy fuel oil all combined in one. And the Corex gas is a low pressure, relatively lean gas that requires rather relatively large dimensions. I'd like to speak a little bit about biomass in general. It's misconceptualized in the sense that it's often used in one term, biomass. But there's a huge variety of biomasses in the world, and it exists in huge abundance. It's the quantities of the biomass we receive or receive from agriculture is vast, and the diversity is equally large. We see that in its physical geometry, physical characteristics, but certainly also its chemical characteristics. One of the fuels that resembles coal the most is wood, and it's sort of in a category for itself. And therefore, that particular fuel is uniquely usable as a conversion fuel for utility power plants. The chemical composition of the large group of other biomass, particular agrobiomasses, does not make them particular fit for conversion. Maybe supplement 5 to 10%, as was mentioned by NTPC, but certainly not full conversions. What we see in this chart here is the representation of the ash deformation temperature of various biomass fuels. On the very far left, you will find olive cake. Olive cake is an industrial waste, biomass waste product from the olive oil production. There are other characteristics of biomass that are of interest, among them the potassium, the chlorine, the sulfur content. Right here, I'm just particularly focusing on the deformation temperature, and we will see that it is nearly 1350 degrees centigrade, which is very, very high deformation temperature. And on number 3 from the left, you will find wood pellets, which is around 1200. It typically ranges between 1100 to 1250. A very adequate fuel. It has low chlorine, low sulfur, low ash content. Very, very good fuel but there is of course some logistic issues about bringing that to the plant. If we go to the very right of the chart, you will find something like palm tree, which typically can be a waste product from the palm oil production. We see that in Malaysia, Indonesia, we see that in Ivory Coast, but the problem with that is that the deformation temperature is extremely low. At least some samples have shown that. So there's a huge variety of ash melting points, depending on the type of biomass fuel, depending on where it grew, its natural characteristics, etc., which does not make the majority of biomass fuels not adequate for neither co-firing or full conversions of power plants, utility power stations. What we would see when we fire this kind of fuel in a power plant is this. We will see massive slagging, and on utility stations, that would be a typically reason to shut down the power plant. This is a picture for a plant designed specifically for these fuels, and this is actually a normal operating condition, meaning that the boiler is designed for this type of slagging. So this is the BWSC biomass boiler that can take in straw or any kind of agricultural biomass with low ash deformation temperature boiler design. It's based on a vibrating grate combustion technology. There is on the far left a conveying system that brings straw bales. It could be paddy straw or cereal straw in Europe typically. A shredder and a stoker that pushes the fuel onto the grate. We have pinning superheaters that is exposed for slagging. They're designed for it. They're supposed to be slagged. It's a part of the design. And thereafter, we have traditional economizers and flue gas coolers. We have also our own sort of combustion air preheating system that is built on not on tubular, not on rotating air preheater, but with there's a transition of heat from the flue gas to the air using water as a heat carrier. In principle, we do that in reverse order so that we start by heating up the air, cool down the water, and then we take out the heat from the flue gas. Therefore, we call it reverse heat shift system. It's quite unique and gives a lot of advantages in also controlling the flue gas temperature out of the boiler. Yes. So looking into India, I call this the Indian untapped resources. I'm not sure that these numbers entirely are updated, but if we look at particular pedestal, there is large quantities of agro residues in India. Of that, you will find that if we sort of transform that into an equivalent of power that actually, based on our biomass boiler technology and the efficiency that is typical for this kind of technology, equates around 20 gigawatt electrical power. So there's academically spoken, there's a large potential for utilizing this untapped resource to something useful rather than field burning. And we do know that that field burning does not only release harmful pollutants, but it is certainly a potential source that literally many places in India goes up into smoke. It certainly also did that here. I remember from my own childhood that fields were burned off every summer after harvest, and it is huge quantities of energy that is released in a very, very short period of time. So this picture here, particularly the low part of it, shows really the transition from field burning and coal as a primary fuel into a more sustainable and green energy strategy. For sure, we can say that despite of all various renewable sources, solar, hydrogen, wind, biomass sort of remains to be a source that can provide some kind of regular or controllable production of electricity and steam for various industrial purposes. And here's a couple of references that we already are working on in India, and I believe that I can say that we have a couple of new orders in the book. So it sort of looks quite good for the Indian market in this sense. Last slide is a slide of the United Nations Sustainability Goals. There's 17 of them altogether. They're not equally relevant for the industry that we are representing, but quite good handful of them are actually. And I think it's important to understand that these goals are here to stay. They are here to be guidelines and role models, so to speak, of what we should be looking into in the future. They will be coming towards us whether we want it or not. We better prepare for that. And therefore, my closing remark for this presentation will be that we better be prepared for opportunities that might not come than be unprepared for one that does. And that will be my final words for this presentation. And I thank you for your attention and the time you have spent to listen to me. Sir, you are muted, so we cannot hear you.
Sorry. Yeah, thank you very much, Mr. Question. Very useful presentation regarding biomass and its potential in India. We look forward to have more interaction with you.
Yes.
And I think participants may have some questions. We'll take it at the end of the session. Thank you very much.
You're welcome.
Next session will be floating solar power plants by A.K. Shukla, IGM, NTPC.
Mr. Shukla, can you hear us? Mr. Shukla?
He is offline or?
No, he's online only, sir.
Yeah, he has come on video. Shuklaji, I think you are muted or something. It's not. Hello.
So we cannot hear you, Mr. Shukla. Okay. Your presentation is coming up, sir. So we are unable to hear you.
Is I think his microphone icon is also not visible on the screen.
I'll just speak to him, sir.
Yeah, please.
सर आपका आवाज नहीं आ रहा है सर.
Mehul?
So I'm speaking to him, sir. A minute, sir.
Yeah. Yeah, please.
Try, sir.
Yes, good morning to all.
Yeah, please go ahead.
Okay, so as we all know that this floating solar is a new area and lot of advantage with respect to the land solar. And in India, this renewable is taking a big shape, and mostly we are going in the land solar. But if you see the floating solar, so a lot of untapped advantages are there. And in India, we are also putting a lot of floating solar. So let us see what are the advantage why we can tap this floating solar and what are the challenges, and then we'll talk one or two slides for the floating solar global scenario and Indian scenario. As compared to the land solar, so energy production is better in the floating due to the cooling effect. And the second thing, as we all know that in India, the land is the main challenge, and a lot of water bodies are available, which can be used to put this kind of floating solar plants. So in India also started in a very baby step, like in kilowatt, and now we are putting in the megawatt, and currently around 2,000 megawatt is in the pipeline. Second thing is in the most man-made reservoirs, it reduces the water evaporations, and many of the dams and irrigation systems, they have the power using systems, so that can be also be leveraged by these floating solars. So that is the extra advantage what we get in the floating. And as in the hydro plant, if we put the floating solar, it can give the complementary advantage. So in the day we can, where radiation is high, we can get the solar, and then in the peaking or the for balancing power, we can use the hydro. And one more advantage in the floating, consume the less land as compared to the less space is required. For this ground mounted, you require around 4 acre per megawatt. In the floating, more than 2.5 acre is required for. So space is also requirement is also less. Apart from that, you don't have any soiling losses because in the land floater, a lot of dust is there. You can do the maintenance and the quality of panel can be maintained. And in erection also, with as compared to the land, you don't have much civil work except anchoring and the mooring, and so it is quite less as compared to the land solar. We have the few challenges also, so that's why it has not picked up, but now it is picking up as cost is going down. So capital cost is a bit higher, around 20 to 25% as compared to the land solar. And there is potential contamination of the water because floater or floating platform that is made of HDPE. So that is a potential contamination also. And this floating technology is also emerging. And there is limited understanding of the technology. And standard is also getting developed. And as we told that this is emerging area across the globe as well as in India. So floating solar specific standards and guidelines are being made. In India, we have huge water body, but we don't have any structured, apart from the man-made, we don't have the data. And especially we face the challenge in the floater because we have limited capacity of the manufacturers. So capacity, that is also a challenge. And since we are installing in the water and if the water depth is high, so a lot of safety issues during installation. And in ODM also, if you need to replace the panel and all, so that also can become a challenge. If you see the global scenario, as we told that this is the most emerging, and floating solar started from 20 kilowatt in 2007, then picked up commercial 175 kilowatt in 2008. And then big pressure happened in 2016 and 18. And now around 2000 megawatt installed across the globe, floating solar. If you see this is the global scenario, and India is not way behind this. You see the Indian scenario, in 2019, this tendering is around 1800 megawatt in the process. And if you see the potential of the floating solar, I have taken only these water bodies. If certain percentage also we can take. So what is the potential of this floating solar which can be leveraged? I have taken a very conservative based on this report. Around 5% if you take there around 12 gigawatt potential is available. So that can be leveraged. If we talk about the floating solar technology part, so few parts are common with respect to land, like PV modules. Inverter can be central and string. And things which change here is floating structure basically. And anchoring and mooring and since it is in water body, so require the different kind of cables and wiring. And then transformer, which is common for land as well as for solar. And this floating technology is developed by some steel and pair and many other manufacturers. They have some as patented also. So this is one of the technologies. One is the main floater. Then you have the support structure, and then you have the panel, and they are floated in the water bodies based on the CFD analysis. And so this is a floating platform. The main thing is anchoring and mooring because we don't have any piling here. So anchoring and because they are in the water bodies. So anchoring and mooring is very important, and we have different ways to do the anchoring and mooring. If the reservoir is man-made or Like in the power plant, we use the LDP lining in the reservoir. So we do the anchoring outside of the reservoir. So different ways to do the anchoring and mooring so that they remain safe. This is again 1 megawatt means megawatt size solar. Here in this, the anchoring was done outside of the reservoir, and here the anchoring was done through dead block in the reservoir. So generally, this floating solar has been changed in the man-made reservoirs, and the anchoring and mooring are designed based on by doing certain software analysis, and whether we can put inside or outside, it depends upon the situation. And type of inverter, they are similar to the land. Either we can have the single inverter or we can have the string inverters based on the requirement. And as I told, this is emerging technologies, and the cost is also, as economy of scale is picking up. The cost of this solar plant or electricity generated is coming down. If you see the earlier, cost was quite high, around 50 rupees per kilowatt per watt. Now it is come down to around 35. So it is coming down, and due to the economy of scale, and we can leverage a lot of water bodies, as I told. And this is the project cost, breakup cost. So mostly cost of the by the lab, around 20 to 30% cost is the water cost. So this was a short presentation, and I really apologize for the inconvenience caused due to the voice.
Thank
you, madam.
Thank you very much.
Thank you, sir.
Thank you very much,
Thank you, sir.
Subhaji. It's a nice presentation. We have concluded the fourth session. We have any questions, Mr. Mehul, from the participants?
Yes, sir. I have few questions, sir.
Yeah, please go ahead.
Yeah. Can you hear me, sir?
Yeah, please.
I have few questions, sir. I'll just ask. I think the first question is for Mr. Lincoln. Mr. Lincoln, there is a question by one of the participants. What he says is that we hear that the iron and steel sector, fertilizer sector, and some of the chemical sectors would be the first one to go for hydrogen-based plants. So, what do you think will be the priority? I mean, do you think power sector would be the immediate priority when it comes to hydrogen-based generation?
That's a great question. My familiarity is really with the power sector, so I can't speak to fertilizer or other uses. But I don't think there's a need, frankly, to prioritize. I think if hydrogen is a good fit, then the project should be pursued. Whether it's power generation or fertilizer or what have you, it really all depends on the local conditions and the local needs.
Okay, thank you. Actually, I think just to give a background to this question, I think this question came because of what we have heard in the Indian context, that in the Indian context, what we have heard is that maybe the iron and steel sector, the fertilizer sector would be given the earlier priority than the hydrogen-based power generation. Maybe that was the context behind the question.
Yeah, that would make a lot of sense, especially in an Indian context.
Thank you. I think the next question is for Mr. Surendra. Mr. Surendra, the question is, what would be the effect what has been the effect observed by NTPC of utilizing biomass on mill performance? So could you hear that question?
Am I audible?
Yes, sir, you are audible, sir.
Yes, sir. Actually, in mill performance, with respect to mill performance, definitely mill output will come down, and we have noticed a slight increase in the mill rejects in some units. Its mill capacity will come down because of this. We are reducing mill inlet temperature because of the volatile matter, high volatile matter in the biomass. So due to that, we are reducing mill inlet temperature, and capacity of the mills are slightly coming down, not appreciable, and our firing quantities are very less now because we are not able to further check also what is there.
Another question to you only, sir. The question is regarding the availability, sir. I mean, for the Dadri unit, we understand there could be availability from the nearby Haryana and the Punjab states. But for the other units, is it still available? And how much at an annual level are you being able to use?
No, actually we have our quantity we are getting almost from Dadri and Mauda. In Maharashtra also we are getting almost a seamless supply. But in all other plants, it's not, industry is not fully developed. This biomass pellet industry, it needs to develop. Then only we can get continuous supply. That already I have given in the presentation. So supply chain management, I think one subcommittee is there at the ministry level, which will be looking into the development of this industry.
And I think last question to you, sir, regarding the briquetting machine. As of now, I think you have your own briquetting machine. So
No. We are sourcing from outside only. The biomass
okay,
pellets are sourcing from outside. We
okay,
don't
sir.
have any.
Okay, okay. Thank you, sir. Thank you. I think that were the questions. Uh, yeah. That's all, sir. I'll just check if we have any more questions.
Thank you.
Yeah.
Thank you very much. Thank you.
Okay, Mr. Karsten, there's a question to you. There's a question when can BWSC manufacturing can start its manufacturing in India on its own? When is your first boiler getting commissioned or getting functional in India? I mean, he wants to know about the any future projects coming up in India.
Yeah, well, I know that we are under construction of a number of plants, and I personally do not have the exact commission date, but to my understanding, it could be very, very close. These projects have been under process for some time now. However, I personally do not have the exact timeline of these projects on my table, so I can unfortunately not say. But I know that there is a number of new projects coming on for the Indian market in collaboration with BWSC. And I'm sure that this group of projects already ongoing and new projects will start a process where it is more and more recognized how these agro biomass fuels can be utilized on a 100% basis for power production in India.
Okay. Another question I have is for, I think this is for both Mr. Surendra as well as Mr. Karsten. What is the variation in the steam temperature due to variation in your biomass firing rates? Maybe both of you one by one. We can have Mr. Karsten first.
Yeah, I
Mr.
can maybe start out at least. The steam variation on our biomass boilers, well, that depends very much on the moisture content primarily of the fuel. That might not be such a big problem in India, and due to more predictable weather, whereas you can see larger variation in the moisture content of cereal straw. Here you could see maybe up to 25% moisture content here, and it could vary from 10, 15 to 25. So therefore, when we are receiving these fuel bales, or whatever that agro biomass fuel is, we are measuring the moisture content on each individual bale and we are storing them with an XYZ coordinate in the storage, and we know exactly where we have what bale with what moisture content. And this way we can feed them in a more average form into the boiler, so we do not get, let's say, 3 or 4 bales with 25% moisture in one consecutive order. So that is entirely under control. But so I would say that we are in the range ±3%.
Okay, Mr. Surendra, any comments from your side?
But do not, I mean, I'm talking about our 10 to 50 megawatt biomass boilers.
Right.
I'm not talking
Right.
about the co-firing on utility plants.
I got that, sir.
Yes, okay, thank you.
Mr. Surendra, any comments from your side?
Sir, no, sir. Okay, no issue, no problem.
Okay.
Yeah.
Okay. I think we have one question to Mr. Shukla. Hello, Mr. Shukla.
Yeah.
The question is, what is the effect on the aquatic life for using using the floating solar?
As in Indian context, the generally floating short reservoir. So not much studies is going on, but not till now not much effect in the aquatic this one, because it is mostly the man-made reservoir and a lot of space between these. But still studies is going on for the knowing the deeper impact of the.
Okay. Thank you, sir. Thank you. Last question, a quick question to Mr. Lincoln again. I'm not sure. The question is, can the hydrogen gas after scrubbing from an integrated CLO2 plant can be used in the boiler?
I'm sorry, could you repeat that one more time?
Can the hydrogen, I think this is too specific a question, sir. Can the hydrogen gas after scrubbing from an integrated CLO2 plant be used in a boiler?
That is a good question. I don't know.
No problem, sir. We'll check and come back. Prasad, also you can maybe close the session, sir. Thank you.
Thank you very much for the panelists and the participants. We had a wonderful 4 sessions or 4 topics today on biomass, renewable energy, and alternate energy resources available for clean energy generation. First, Mr. Lincoln has given his experience in US utilities, how the conventional coal-based power plants have been converted to hydrogen-based firing, followed by biomass utilization and of NTPC experience. Mr. Surendra has given his presentation saying that 1 to 5% they've already tried and tested in few of their power plants. I'm sure NTPC is doing a lot of research and a lot of field trials in other power plants also, and he has mentioned that due to lack of or non-availability of the biomass in near to the power plants, that's why they are not able to do it. Of course, with a separate cell formed in Government of India Ministry, I'm sure this 1 to 5% it will be increased slowly to higher level of percentage of utilization of biomass. Third topic, which BWSC is covered by Mr. Krasna, was very interesting. He has given how the same boiler with small modifications can be converted to conventional coal fire to biomass firing, and his experience in Indian context, providing smaller capacity power plants fully fired with biomass. And last topic, which is the floating solar, delivered by Mr. A.K. Shukla, NTPC AGM. This is the new trend set by Ministry of Power, Government of India, that because of the scarce availability of the land, all the power stations are looking at utilizing their raw water reservoirs for converting that area and utilizing that to floating solar units. I am sure more number of units will be coming up. and with the challenges faced and the learnings from the already existing or commissioned units, the target of about 2000 megawatt of solar on floating mode of operations, I am sure will be successful. With this, I thank once again all the panelists for sparing their valuable time on this platform and giving a valuable inputs on various fields. Thank you very much. I also congratulate CIA for organizing this WebEx, covering the participants and also the panelists from across the world. Thank you very much. Have a nice day.
Thank you very
Thank
much.
you, everyone. Thank you, all the speakers. Thank you, our session chair as well, for being here. Participants, request you to please join the next session. Again, another interesting session on digitization. We have 5 good speakers lined up. Please join there. Thank you, speakers. Thank you, Mr. Shukla. Thank you, Mr. Kastan.
Thank you
Have a
very
great
much.
day. Thank you, Prasad Rao, sir.
Thank you.
Thank you.